Hello interwebs, welcome to Let's Build Computers. So this video is not exactly the latest breaking stuff, but I find myself in a niche these days of attempting to translate the higher end tech stuff that I'm learning to mid-range people who, like myself, have found their knowledge becoming rather outdated. It used to be that when you were building a PC, you assemble it, you post-test it, you maybe do a BIOS update on it if you need to, and then that's it, you're done. Install Windows, bang. But it doesn't seem to be quite that simple anymore, and that's kind of been the case for a while. XMP is a thing that you sometimes need to turn on, and sometimes it works and sometimes it doesn't, and also your CPU might not be boosting as hard as it could out of the box. And now overclocking a CPU is all about boost and not base clocks, and you might even want to lower your CPU voltage in order to go faster, and it's just, things have changed, basically. So recently I built a demo PC based on a Ryzen 3600 in my shop for the specific reason of I'm out of touch and I need to swat up on this stuff. So this video is about me telling you what my findings were. And this isn't a definitive guide. I don't claim to be an overclocking expert, but by the end of this you should feel like you should be able to competently set up a new PC and not be worried like I was that it might not be going quite as fast as it's supposed to. So let's start with the basic RAM setup. In the past, most mid-range quality builds, to use the Dark Souls terminology, would usually run, say, 2400 or 2600 MHz RAM, with 2666 being the highest that is natively supported by Intel. So you buy your RAM and it gets auto-detected by SPD and it just runs at its rated speed in the BIOS. You don't have to do anything. So the RAM timings that it will be automatically set up to are a table of numbers that correspond to how the modules are accessed, such as how quickly the memory responds after it's addressed, how quickly it can move to a new address, how often the memory is refreshed, how quickly you can access it after a refresh, and so on and so forth. And there's a laundry list of all of these timing numbers. And then XMP came along, which is extreme memory profiles. And that enabled RAM speed to jump up to like in excess of 3 GHz while running at tighter than average timings. The trade-off for this was that you have to manually switch on XMP, and sometimes it'll work just fine, and sometimes it won't. I've got friends who tell me they've never ever had a problem with XMP and it just works. But then I've also got a few friends who either I have switched on XMP on their PCs and they've had to turn it off again, or they've messaged me saying, I turned on XMP and now my PC won't boot, what do? So understandably, I approach the midlife cycle of DDR4 as an XMP skeptic. But it's universally agreed upon now that in modern PCs, both Intel and especially in Ryzen, that you will see a noticeable performance boost from high-speed RAM. And anything with less than 3 GHz is more or less considered peasant tier RAM nowadays. So you're going to need to be on this XMP bandwagon. So first things first, XMP, as I mentioned, stands for Extreme Memory Profile, and it was an Intel development. So on AMD boards that you might find that it's labeled in the BIOS as something else, such as AMP, DOCP, EOCP, or some other marketing spiel depending on what brand motherboard you're running. But all of these things are based more or less using the same XMP profiles. It's not correct to say that it's the same thing, but they are based on the same profiles. It's the same spirit, basically. And when you buy RAM, it's not Intel or AMD specific. You know, if it's XMP rated RAM, any AMD equivalent stuff is going to use those XMP profiles as their baseline. And so when you look into the BIOS for your motherboard, just have a look around, and it's going to be fairly obvious for anyone who's familiar with the BIOS what the XMP switch is. It'll be fairly obvious. It'll be in with the memory settings. So for the purpose of this video, I'm just going to call it XMP all the time because that's basically what it is. So in this build, I've got a Gigabyte B450 Aorus M running Patriot 3400 RAM. And it's a really good example for me to use in this video because XMP on this RAM is not stable at 3400, but it is at 3200. So I can demonstrate the pitfalls of XMP quite well and how you might be able to mitigate them if you're having problems with XMP. So right now we're at stock settings, and as you can see, with XMP turned off, our RAM defaults to 2133, and that's the first thing that we need this video to demonstrate. Just buying decent RAM and fitting it isn't good enough. And in fact, if you buy high-speed memory and run it without XMP turned on, you'll actually find that it hurts your performance more than helps you, because some cheapo RAM that's at say 2600 will just run at 2600. However, buying expensive RAM that's like 34, 36 or 3800, if you don't set up XMP, it's going to default to 2133, and it's going to be running at a massively downclocked speed. So I'll turn on XMP, and it's going to set up to run at 3400 as per the ratings of my Patriot modules. So now we'll save it and we'll see how it runs. So I'm just going to save configuration and exit. And now we'll reboot and we'll take it into Windows. Or not, because we blue screened. Never had a problem with XMP, people say. This wasn't in the script. This bit was not in my script. It was supposed to work. Fine. Well, what I was going to do is go into Windows and run TimeSpy, because TimeSpy is really finicky, and if your RAM isn't solid, then TimeSpy will invalidate and just give you a 0 score. So I was going to take it into Windows and run TimeSpy, which I knew was going to fall over at 3400. Is it just turned off? So it was going to give me a 0 score. However, that has just saved me the trouble. So I guess we don't need to try and run TimeSpy at 3400. So I'm going to take it back into BIOS. And now what I'm going to do is I'm going to drop it to 3200. So if I go into advanced memory settings, yeah, we're still trying to drive at 34. So I'm going to drop this down. I'm going to minus that, we'll plus that. So I'm going to set this up to 32. So my memory multiplier is 32, which is giving me 100, which is my base clock, times 32 gives me 3200 megahertz for my clock speed. So now we're going to run XMP 3200. Save and exit. Whoops. Save and exit. Okay, right. Hopefully I can get back on script now. So this time I'll go back into Windows and we'll run TimeSpy, and we'll use that as a validation method to prove that it's stable at 3200. Right, and there is a score from TimeSpy. It says it hasn't been validated online because this computer's not connected to the internet at the moment. So, fairly meager score. It's an RX 517 here. It does not have a top-end graphics card, this machine. But the point is, we got a valid score out of it. So, we seem to be stable now, but gosh heck it, I want my extra 200 megahertz from my RAM. So, how do we get it up to 3400 if it won't go there using just the automatic XMP settings in the BIOS? Enter DRAM calculator for Ryzen. So this tool will allow you to calculate the likely safe or faster RAM timings that your module should be able to achieve. So this can be used for either overclocking your memory, so you can either calculate the timings for higher than stock speeds. So for example, I could take my 3400 memory up to 3600 or 3800, and it'll tell me what timings it should be able to achieve at those speeds. Or in this case, I can use it to just calculate a more stable XMP profile to get a nice stable 3400 that is fairly nice on timings as well. So we've got to fill this out with a load of information. Firstly, we need to tell it what kind of processor that I have. So I have a 3600 in here, which is 2nd gen Ryzen. If you have a Ryzen 2000 series, that's Ryzen Plus, and Ryzen 1000 series is Ryzen 1st gen. And obviously you got Threadrippers and your other WX series. I think those are the Epics. So we've got Ryzen 2nd gen. Now the memory type, this is the brand of chip that's on your module. So how do we figure that out? Well, you can get a pretty good guess as to what that might be from CPU Z. So I'll start CPU Z. And we've just got to wait for this to scan. And then I'm going to go to the SPD tab and specify an active slot. And this tells me that we've got SK Hynix chips, and they are the 3400 C16 series. So that is almost certainly going to be the Hynix CJR, which I hear is apparently a bit of a peasant tier chip, and that might be to do with why I'm having difficulty just getting 3400, but we'll get to that. So the profile version, this is the profile that DRAM is using. So you start off on version 1 for high quality memory, and you might select version 2 if you've got peasant tier RAM. We should be able to use version 1 for this because we are using performance memory, not just some cheap OEM rubbish. So we're running dual channel memory. I've got 2 modules in dual channel configuration. I'm looking for 3400. My base clock is at 100 because we haven't overclocked our CPU at all. And we've got 2 modules. And then finally, I've got a B450 chipset, or if you've got an X470, that's the same platform. So now to fill out the rest of these numbers down here, we can import the XMP profile. So there's the XMP stuff. And now I'm going to hit Calculate Safe. And it's populated the rest of the table with some timings that are more or less guaranteed to work at 3400 megahertz. If I had a high confidence, we could also calculate fast, and it'll tighten all of those up slightly. However, I'm not looking for breakneck speed, I just want solid 3400 performance right now. So we'll go with the safe options. And in order to help achieve these, it's dialed in just a little bit over stock DRAM voltage. So we'll get to that in a moment. So what I'll do is I'll take a picture of that screen with my phone, and now we're going to jump back into BIOS, and we're going to put all of those settings into BIOS. So let's restart, and I'm going to go into BIOS. So we're going to go into Advanced Memory Settings, and we're going to, firstly, we're going to change our system memory multiplier back up to 34. So we're aiming for 3400. And we're going to set our memory timing mode to manual, which unlocks all of these timing controls. Now, if you're trying to dial in some really aggressive timings, you're going to want to change all of these auto values onto the manual stock settings first, and then dial in your tighter settings one by one, because there's a lot of settings here, and if you change all of them and you just blue screen, you're going to have no idea which one is actually upsetting it. However, because I'm just aiming for pretty safe timings, I already know in advance that these timings work because I've tested them. However, because they're safe settings, we're almost certainly going to have success here. So let's just bash in all these settings manually. So firstly, I've got to get up my screen cap. And let's go. So our CAS latency is going to be 16. And TRCD-DR is 19. Okay, so we've now filled out our timings to the best of my abilities. There are a couple of things that I've left on auto because I could not find a value for them from Ryzen Calculator. And I think that's just because some of the values in the BIOS will vary, but again, I'm not an expert. But basically, I've just filled it out as best I can here, matching it all up. And as you can see, we've left a couple of things on auto, but most things we've now set onto a manual setting. So what I'm going to do now is I'm going to go over to Save and Exit, and I'm going to save this profile. And as you can see, I've already got a couple of profiles where I've been tinkering around with this before. So I'm going to save this as a new one just so as not to overwrite a profile that I know works. So we're going to call this DRAM calc safe. Profile saved. So that way, if my BIOS gets reset, I can load this profile and carry on working with it without having to enter in all those numbers again. And now I'm going to do Save and Exit Setup. So now we've saved those manual timings, and we'll get back into Windows and we'll check in CPU-Z to verify that we're running at 3400, and then we'll time spy again to confirm that it's actually stable. Right, and according to CPU-Z, my DRAM frequency is now at 1696.6, so 1700. And 1700 times 2 is 3400, so that gives us our 3400 speed. And we'll also find that these timings also match up with what we've been dialing in. So that all looks good. So now what I want to do is make sure that's stable. So I'm going to go ahead and run 3D Mark again. So I'll run through 3D Mark and we'll make sure that gives me a valid score. And now as you can see, we've got a successful time spy run at 3400 megahertz, whereas previously just using the automatic XMP profiles, we were blue screening just trying to get into Windows. If you've got time to spare and kick-ass memory modules, you can try dialing in the fast memory timings or now nudging up to a higher clock speed on safe settings, and then you may be able to get even more out of your memory. But when you start chasing numbers, just remember that you're trading megahertz for timings, and there'll be a point of diminishing returns where the wider timings that you have to run at higher clock speeds will slow you down more than the high clock speed is speeding you up. So you need to find a balancing point based on what hardware you've got. So now, as one last part to this video on memory, I'm now going to run exactly the same memory modules in a better motherboard, and I'm going to see if I get any different results or not. Okay, right, I've changed my motherboard out to an Asus Republic of Gamers Strix X470F Gaming. So much higher tier of motherboard now. This thing is nearly twice the price at retail cost of the Gigabyte. So let's see if with the same CPU and the same memory modules, do we get any kind of change? So let's switch over to the capture. I'm in BIOS at the moment. Okay, let's just try doing this from the easy mode. My objective here is just to see if just simply switching on XMP will magically fix everything. So if I turn on, so on the Asus here, they call it DOCP, which stands for something, whatever, something overclocking profiles, whatever. But here, as you can see, DDR4, 3400, 16, 18, 1836, 135. So looks about right for this RAM of what we were running previously. So let's save that and we'll see if it just runs at that as standard with no faffing about. So I'm going to save and exit. Bam. And now we'll let it start up. We'll take it through a time spy run and we'll see if it just works. And in our memory timing, once again, our DRAM frequency is at 1696.6, so 1700 megahertz. Times 2 for DDR gives us our 3400. So we are at the correct frequency now. So I'm going to run it through time spy and we'll see if it gets through time spy. And we got a perfectly valid result. So just goes to show that having a good motherboard is also going to have a big impact on how much trouble you have with your memory timings. So now the Gigabyte motherboard that I was previously using, I had a lot of hassle with the BIOS on that motherboard, as anyone who's watched my previous videos will know. So I'm assuming that just a NAF BIOS on that motherboard is the reason why I had to run custom timings just to get to stock speed on my RAM. However, if you're having difficulty with that, now you know how to get to the speed that your RAM should be running at. However, with now what appears to be a much better motherboard on the bench, let's see if we can get the RAM up a little bit further. Let's see if I can go straight up to 3600. And what that achieves for me. Because it's also worth noting that we have scored slightly lower than we did before by a matter of 6 points, but still we're at 3400. But without the custom timings, we've actually come just slightly short. But that could be within the margin of error. Who knows? Either way, let's bump up to 3600 and see if we get anything out of that. So I'm going to go back into BIOS and I'm literally just going to say 3600 and just see if it just does it with no faff. So we're on DOCP for 3400, but I've just dialed in a memory frequency of 3600. Still no custom settings. I've literally just said, give me 3600 megahertz. So once again, I'm going to save and restart and we'll see if it runs at 3600. Okay, we're into Windows and our DRAM frequency is up to 1800. So we're now at 3600 DDR. Again, I'm going to time spy. I'm going to use that as my baseline to see if we're stable. Okay, once again, we got through time spy with exactly the same score. Now, it's worth noting that based on some other testing I've done, I don't think time spy really notices much of a difference in RAM speed. However, other games do. RAM speed does matter quite a lot. If you check out Jay's 2 cents, he did a couple of videos recently about different memory speeds and configurations in a lot of mainstream games. And the differences in performance that he saw there are very, very noticeable. So although you're not seeing much real difference in the speed between our RAM settings here, trust me, it does matter. I'm just using time spy as a stability test, not a performance test. Anyway, the point is we're now at 3600. We've just got a free upgrade of our RAM just because we have a better motherboard. So now, is this because this motherboard is particularly good or because my other board is particularly bad? I think it's the latter. I think that Gigabyte board has such a trash BIOS that it's difficult to really do anything in it. And this ROG Strix board that I'm using here clearly has no such issues at all. And given some more time, I could probably eke quite a bit more out of this RAM because we haven't even started drilling into custom timings yet. But I'm going to leave that for another time. I think we've covered all the basics here. So I said at the start of this video, the objective was to show you how to get into memory configuration and how to make sure that you're getting the most out of your RAM. And I think we've covered that. I've shown you how to approach XMP profiles, when they can be bad, when they can be good, and if you're having difficulty with XMP or you're trying to overclock, how you can approach overclocking your memory. So past that, I hope that was all useful. If you've got any other tips that you don't think I covered here, because this was by no means an exhaustive video, if you've got any additional tips that you think people ought to know, stick them down in the comments below. I'm going to do another video similar to this one where we start going into the basics of overclocking a Ryzen. So that is using Ryzen Master and whether you should take your voltage up, down, left or right and all of that stuff. But I'm also learning this stuff as we go. So, come along with me for the ride. Thank you very much for watching. I'll see you all next time. Bye for now.